Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Welcome back, everyone. In the previous section, we have seen what blockchain is and how blockchain works, and what are the components of blockchain and how those components work together. In this section, we are going to build supply chain DApp with Hyperledger Fabric. And this project is organized in the following 5 sections. First one is blockchain supply chain design. This is the section that we are going to see in this video. And the second one is writing chain code as smart contract. The third one is compiling and deploying the written smart contract, and running and testing the smart contract would be fourth one. And developing an application with Hyperledger Fabric through the SDKs will be the final chapter. So in this project, we will put all the conceptual knowledge of Hyperledger Fabric that we have learned in the last session, and we put together all this, and we will design and build the simple supply chain blockchain application called Pharma Ledger Network, in short PLN, using Hyperledger Fabric. So this gives you a taste of blockchain-enabled global business transactions with greater transparency, streamlined supplier onboard, better response to disruptions, and secure environment. Specifically, the PLN, which is Pharma Ledger Network project, it illustrates how blockchain can help manufacturer, wholesaler, and other supply chain members like pharmacies to deliver a medical supply. So let us get into the details of blockchain supply chain designing part of it. So the traditional supply chain usually lacks transparency and reliable reporting. Large organizations have built their own system to enable global control of their daily operations while recording the transactions between suppliers and distributors in real time. Other small companies, however, lack the information and have limited visibility and trace their product at any given moment. That means in their entire supply chain product process workflow, from the production to consumption, the transparency from upstream to downstream is very limited. This could lead to inaccurate reports and lack of interoperability. The summary of this paragraph is nothing but whenever a supply chain in the current ecosystem, the supply chain is handled in real time using a centralized database where a person has a visibility only to the central database. So with blockchain in place, every participant who is part of that network can see the real time data. By design, blockchain is a shared ledger, transparent, immutable, and secure decentralized system. With the meaning of all this shared ledger, transparent, and immutable terminologies we have learned in the last section. As such, it is considered to be a good solution for traditional supply chain industries at registering, controlling, and transferring assets. Indeed, the popularity of blockchain and its adoption in part stems from its use case in the supply chain system around the world. This is not the only use case where blockchain is used. There are many use cases where industry is coming forward to improve the supply chain, whether it is in the form of whether it is the supply chain of pharmaceutical equipment or pharmaceutical drugs, or the food that we eat or the vegetables. There are many supply chain which is a use case for the blockchain. So smart contract, which defines business function deployed in blockchain, can be accessed by multiple parties in the blockchain network. Each member in the blockchain will be assigned unique identifier to sign and verify blocks they have added to the blockchain. We have learned about the smart contracts and the MSP in the previous section, and that is what we are talking about here. So during the life cycle of the supply chain, when authorized members in the consortium network invokes a smart contract function, the state data will be updated, after which the current asset status and transaction data will become a permanent record in the ledger. Likewise, the processes related to assets can easily quickly move from one step to another. The digital transaction in the ledger can be tracked, shared, and queried by all supply chain participants in real time. It provides organization with new opportunities to correct problems with the supply chain system as it revolves around single source of truth. This means using smart contract, we are going to put an asset on the blockchain network, and the change of owners or change of the state of that asset can be tracked and can be stored immutably in blockchain system, which serves as a single source of truth, because your data is not bound to one server. Your data is available in every peer. So in this section, we'll discuss a simple supply chain system, and we will build pharmaceutical ledger network, in short PLN, use case with the application design. So this will give you good foundation on how to analyze and implement an application based on the Hyperledger Fabric. We'll start with analyzing the business process workflow, identifying the organization in the network, and designing the consortium network. We'll also define the smart contract function, which will be performed by each organization. So coming to explaining this section, this means, so you will once you so when you start building the Hyperledger Fabric application, knowing what are the organizations which wants to be part of this network is very important. And once we identify those organization who wants to come in and form a network, we are going to design a consortium. As you already know, it's nothing but a group of organization willing to come as a network to achieve a business, achieve a supply chain or a business deal. So we are going to store the assets using smart contract, which we are going to see in writing smart contract section. Now let us understand the supply chain workflow. Now let us take a look at the organizations in PLN business scenario, which you can see here. I'll explain more details of this. So this is the real world use case. So first one is, so if you consider this network as Pharma ledger network, you have three organizations. One is manufacturer, wholesaler, and pharmacy, which you can see, which you can note from from the diagram. So manufacturer makes the equipment and ships it to the wholesaler, and the wholesaler distributes the equipment to the pharmacy. The pharmacy, as a customer, receives the equipment, and supply chain workflow is completed when it reaches here. So the three entities over here forms the network, and that is called consortium. So let us see now details of what a consortium is. So we can see in the process workflow, our PLN involves three organizations. One is manufacturer, wholesaler, and pharmacy, which you have already seen. So these three entities will join together to build a consortium network to carry out supply chain businesses. The consortium member can create user, invoke smart contracts, and query blockchain data. Now let us understand what do you mean by that. So this table depicts the organization and users in the PLN consortium. And you can also see the same in this picture as well. So I'll explain this picture in detail. So as you can see, the organization name is manufacturer, which you can see this is manufacturer, and the user that it is associated with is Bob. So we can also call him client, and the MSP that he is associated with is with that is organization one MSP. So using org1 MSP, Bob's gonna identify himself and he is gonna talk to the peer which is at the endpoint. So which is at the endpoint peer0.org1.example.com. So we are going to look into what Docker containers and how we are going to bring up this peers and everything in the coming section. But for time being, let us understand this is an endpoint which is running at the address peer0.org1.example.com, and the client who is Bob for manufacturer organization gets its identities from the MSPs or the certifications from R1 MSP, and he can talk to the peer. Same with wholesaler and pharmacy as well. Wholesaler has a user Alice, which you can see here, and Alice gets her certificates or CA from R2 MSP, and it is at a endpoint po0.org2.example.com. And the third entity is pharmacy. So pharmacy has a client Eve, which is also a user, and Eve gets the CAs from arc3 MSP, and he or she can talk to peer using those arc3 MSPs. So as to summarize, in a PLN consortium, each of these three organizations has a user and a MSP and a peer, which is user, MSP, and a peer. For example, manufacturer organization, we have Bob as an application user. We have R1 MSP as a MSP ID to load the MSP definition. And we define anchor peers with hostname peer0.org1.example.com to gossip communication across. So we have learned about what anchor peers are in the previous section. So we are going to define it programmatically in the coming lecture. So similarly, wholesaler is the second organization and Alice is the application user and its MSP is arc2 MSP, and Eve is the pharmacy organization user um, for the pharmacy. Sorry. So client is Eve for pharmacy, and arc3 MSP is the credentials that is used by Eve to communicate to peer. So as you can see, we have three peers, and we have something called PLN channel. So we have seen what do you mean by channel in the previous section. And we also have one more orderer node, which is there at this endpoint orderer.example.com. So including the orderer, we have four peers as you can see in this picture. So we are going to see how we are going to bring up this network, or how we are going to simulate all these peers, and how we are going to form this entire blockchain network ledger, and how we are going to create the PLN channel in the coming section. So we have since installing and deploying this PLN in multiple physical nodes may not be in the scope of this project. So we will define one peer for each org representing manufacturer, wholesaler, pharmacy, and an orderer node. So the channel PLN channel provides the private communication mechanism that will be used by orderer and other three orgs to validate and execute the transaction. More of these are coming in the later section. Now let us see the PLN lifecycle. So as you already know, with any supply chain, we have to put an asset into the blockchain, and we have to monitor that asset, and we have to execute the smart contract in such a way that that assets will get changed. For example, the ownership might change for that asset, and as it
Thanks for watching. Feel free to add your questions as comments down below.
moves from one phase to another. So this is what the life cycle is. So the life cycle is nothing but the life cycle of an asset where it transforms from one phase to another in the blockchain. So in our scenario, so we are gonna mark this as an asset. So we are gonna mark an equipment as an asset, and we are gonna capture all the details or all the attributes that identifies that particular asset. So as you can see from this diagram, so we are going to consider this as an asset. So a piece of equipment with equipment ID as this, and and there are a couple of other attributes which you can see, which we have captured over here. This uniquely identifies that particular attribute, that particular equipment in the blockchain. So this we can call it as an asset. So equipment attributes and values. Here we define a unique identification equipment number to represent an equipment, which is equipment number, as you can see here. Each equipment is owned by an equipment owner at certain period of time. In our case, we define three different owner: manufacturer, wholesaler, and pharmacy. So the previous owner type and the current owner can take three different values, which is manufacturer, wholesaler, or pharmacy. So there are different attributes that you have defined here. So this will makes more sense when you go and execute the smart contract, and when you completely understand the workflow and the changes that has to take place for a particular asset life cycle. So when a manufacturer makes a piece of equipment and record it in the PLN, the transaction result shows the equipment with a unique identification number 2000 in the ledger, and the current owner current owner is Global Equipment Corp, which you can see here. Current owner type and the previous owner type is same, which is manufacturer. Why? Because manufacturer has manufactured this equipment, and the currently he has not initiated the process where he has to move it to the next organization. So at this point of time, the manufacturer becomes the owner of this particular equipment. So after a few weeks, the manufacturer ships the equipment to the wholesaler, and the equipment state will change, including the ownership, previous and current owner type, last update as well. So this is what the previous asset looks like. Previously, the manufacturer is a Global Equipment Corp, which won't change. And then there are a couple of other things, for example, equipment number, equipment manufacturer, equipment name, which won't change. But the owner name and the previous owner name and the current owner name changes. As you can see here, the previous owner name in the previous asset snapshot is manufacturer. Here the previous owner is manufacturer, and the current owner was also manufacturer because manufacturer has not initiated the transaction. Now that the manufacturer has initiated the transaction, and he has supplied that particular equipment to the next stage, which is wholesaler. Now that equipment lies with the wholesaler. That's why the current owner type is wholesaler. And the time also updates. The updated time, as you can see, the last updated is January 1st to 2021. Here the last updated is January 20, 2021, but the created date stays the same. Moving on to the next process. After 1 month, the pharmacy finally receives the equipment order. The ownership is now transferred from wholesaler to pharmacy as shown in the below. So as you can see from here, the owner name is Pharmacy Corp and the previous owner type is wholesaler. Now the current owner type is pharmacy. Now from this, you can clearly see that the asset lies with pharmacy now. So equipment at the hand of pharmacy. With the same equipment identity, the peer organization can trace the equipment's entire history of transaction record by looking up the equipment number. So we will write a smart contract where you can actually see the history, or what all the what all the stages that an asset has gone through, what all the stages this equipment has gone through during its phase where he has to reach from manufacturer to the pharmacy. In this PLN workflow, we have learned there are three steps in the entire life cycle. Originated from manufacturer, the equipment moves from the wholesaler to pharmacy. As a result of making an equipment, the wholesaler distributes and pharmacy receives the transaction. With the above design and analysis, now we can start to write the PLN smart contract. This is about designing and analyzing the business use case which is in your hand. Now that we understand how this works, let us move on to writing the smart contract, and I'll see you in the next section. Thank you. Let us move on to writing chain code as a smart contract. We have discussed how equipment state and attributes change during the life cycle of transaction as the equipment moves among different parties in our pharma ledger network. A smart contract is a program that implements the business logic and manages the world state of business object during the life cycle. During deployment, it will be packaged into chain code and it is installed on each endorsing peer node that runs in a secure Docker container. The Hyperledger Fabric smart contract can be programmed in Go, JavaScript, Java, and Python. So in this section, we'll look into smart contract implementation for our PLN using JavaScript. Now let us look into the code part of it. So this is the structure of the project that you will receive. So we will see all the other other folders, and we will discuss everything in detail. But for this section, we will see what are the dependencies that we need for writing the smart contract and how the smart contract file looks like. So in Node.js, if you are familiar with Node.js programming, you know that package.json is the main file where you depict the dependencies that you want for that particular project, and you will write the scripts that has to be executed when you write a particular keyword, and there are other attributes like name, version, description of the project, and things like that. For blockchain project, dependency section has two main dependencies, which is Fabric Contract API and Fabric Shim. So these are the two main dependencies that we need to write a smart contract. So the Fabric Contract API provides the contract interface, and it has two critical classes that every smart contract needs to use. One is context and another one is contract. So we are going to see how this is used in smart contract, which is Pharma Ledger contract. So Pharma Ledger contract contains the smart contract which lies inside the lib folder of contract folder. So let us open this. So this is how a general smart contract file looks like. First line is contract. So as we have told, Fabric Contract API provides the contract interface, and it has two critical classes that every smart contract need. One is the contract and the other one is context. So the contract has methods like before transaction, unknown transaction, create context, which are all optional, but it can be overridden in subclass. For example, you are writing a class Pharma contract, which is your contract, and it extends from the contract class. So in JavaScript, explicit contract class name can be specified by using its superclass to initialize itself. So this is the explicit contract class that you are specifying, and you are using the contract class, which is an already existing class, which is a superclass, to initialize itself. And context provides the transactional context for every transactional invocation. What do you mean by that? So when you invoke a transaction, for example, a person from an organization manufacturer invokes the transaction to another organization. So the transactional details that has to be present, like who is the person who has initiated the transaction, what is the MSP or the certificates that he is using, at what time he has raised it. All these transactional details are present in the context class. So context class provides the transactional context for every transactional invocation. It can be overridden for additional application behavior to support smart contract execution as well. So to be specific, context is something which you write it for every method. If you can see, you have make equipment, you have wholesaler distribute, and you have pharmacy receive. For all of these methods, you have one parameter in common, which is context. So using context, you can get the so using this context, you can get all the details that is necessary for that transaction, so which gives the transaction context. So this is how smart contract looks like using smart contract looks like, and this makes use of this main libraries. So these libraries are very important for you to remember and very important for you to import. Without this, you cannot write a smart contract. Now, as you have seen the outline of this smart contract, let's move on and let's build our knowledge on top of this. In the previous section, we have seen that the Fabric Contract API, which is a library, it provides the contract interface, and it has two critical classes, which is contract and context. So in a Pharma ledger contract, and so we are going to have the implementation our own smart contract implementation. So in our Pharma ledger contract implementation, we'll extend the details of a contract from the default built-in contract class, which is the contract which you can see from the above code, and we have internally imported that using the Fabric Contract API. Now inside this, so when we write class Pharma ledger extends contract, meaning our Pharma ledger contracts get all the properties which are there built in that contract class. Now let us see what do you mean by constructor. So in this constructor, we are going to use this namespace, which is arg.pln.pharmaledger.contract. So this your name that what you are seeing, this gives a very descriptive and unique namespace for our contract. And giving a unique namespace is very important when you write a smart contract, because if you have multiple smart contracts in your chain code, as we already know, chain code is a bunch of smart contracts. If you have multiple smart contracts in your chain code, it is very difficult to identify your namespace or your smart contract. So namespace are very important to identifying your smart contract. Then you have a method called async instantiate, which takes context as a parameter, which is a mandatory parameter that you are passing if you have that you have to pass in order to write any method in your smart contract file. So async instantiate is the method that you can call once you install and instantiate your chain code on the ledger. So instead of
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
instead of invoking a transaction which is gonna perform some business task, you're gonna just invoke this instantiate transaction, which is gonna give output as instantiate the Pharma ledger contract, which internally means everything is successful and your smart contract is good to go and you can execute the transactions further. So this is the main advantage of writing an instantiate method like this. That is about writing the smart contract in the initial stages. Now let us look into how to write all the transactions which are related to our project specific Pharma ledger contract. See you in the next section. Now let us move on to the transaction logic. As we have discussed before, Pharma ledger contract will need three business functions to move equipment owner from manufacturer to wholesaler and finally to pharmacy. So these are the three functions which depicts the three business functions that we need to do the transaction. So the manufacturer will be initialized with an equipment entry and manufacturer creates that entry. As you will notice, these function accept a context as a default parameter, which you can see here. So all these method has one common parameter, which is context. So we have discussed what we will get out of context in the previous session. So as you will notice, there are functions that accept as a context as a default first parameter with the equipment related arguments. So these are the equipment related arguments and the context. These are the context and equipment related arguments. So these are the client inputs that we have to receive as part of making this asset on the blockchain, or doing some transaction or doing some modification on top of the asset. When make equipment is called, the function expects four attributes, which is manufacturer, equipment number, equipment name, and owner name. And these are the attributes that forms the attributes of the asset, which we are going to put it inside the blockchain. Now, let us open this make equipment. So this is a function. As you can see, this is one method that we have written over here, which is make equipment. So it is called by the manufacturer, and manufacturer adds the equipment that he has manufactured in his company. So we have got manufacturer, equipment number, equipment name, owner name as the property that we need to add it as an attribute to the asset. So now let us create an object out of it. Before that, there is let dt, which is date and time, and we are gonna take that from new date, which is a object that is already available in JavaScript. So this will give the date and time. So we need to capture the date and time when this particular asset has been created by the manufacturer. So that is why we are taking the date and time. Now we are going to take equipment number, which is this one, manufacturer, which is this one, and equipment name, which is the argument, this one, and owner name, which is the last parameter. Now previous owner type is manufacturer, because manufacturer is the first person who is producing this asset. which is he is producing this equipment, and current owner is manufacturer, because now the transaction has not been initiated by the manufacturer to pass on the equipment to the next organization. So that is why the current owner is also manufacturer. So created date and time, as we have captured here, we are going to put that value inside create date and time, and last updated time will also be the same as the updated time over here, captured time over here. Now this is an interesting statement. Await ctx.stub put state equipment name, equipment number, which is what we have got here, and we are gonna do something like buffer dot from, then JSON stringification of this equipment object that we have created, and we are going to feed that to buffer, and that we are going to store it against the equipment number. So now let us see what this is. Now ctx.stub.putState, it will store the equipment initial state value with the equipment number as a key. So this is a key that is used as to identify this particular object, and this is the equipment number key that is used on the ledger. The equipment JSON data that is stringified. So this is the equipment JSON data, and it is stringified using JSON.stringify, and then we are going to convert it into buffer. So to understand clearly, you are going to feed the equipment object that you have created over here, then we are going to JSON.stringify it, then the output of the JSON.stringified you are going to give it to buffer. So why you need to make it to JSON? Why you need to convert it to buffer format? Why can't you just give it in the JSON or the stringified JSON format? This is required because the buffer conversion is very much required by the shim API, which is the ctx.stub, whatever we are using. This is the requirement of the shim API to communicate with the peer. So this is the context, and it is giving a method stub, and put state is the method that we are using in order to put the asset using this identifier, which is equipment number, and the object which we have created, which is nothing but an asset. So the function uses this new date, which we have already seen. When the transaction data is submitted, each peer will validate and commit the transaction, which we will see programmatically how it will happen in the coming lecture. So after this, so once the client calls this method, so the equipment will be recorded by the manufacturer, and this means that an asset, the equipment asset, has been created on the blockchain. Now moving on, so this completes making an equipment by the manufacturer. Now let us move on to wholesale distributor. So this is wholesale distributor function. As we have told before, we are taking CTX, which is context, as the first parameter, and we are getting equipment number and owner name. So in the wholesale distribute function, we first query the current equipment ledger by calling ctx.stub get state equipment number. So we are passing equipment number. Here we are trying to query the ledger by calling this function. So get state is the function that we are calling to get the details of that asset with this particular equipment number. So once the data returns, so here is where the data that is returned from this particular method, which is get state. Once it is returned, once the data is returned, we need to make sure that the equipment as byte, which you can see here, is not empty, which means if it is empty, which means there is no asset with this equipment number. So we need to check whether it is empty or not. That is what we are doing in this this particular statement in line number 77. So we are checking whether the equipment as bytes is 0 or not, the length is 0 or not. So we are going to check whether it is a valid number. Since the ledger data is in JSON string byte format, it is needed to convert encoded data to readable JSON format by using buffer.from.toString UTF format. So here we have got that the the value exists. This is not a null value. So if it is a null value, this will throw an error. If it is not a null value, then we are converting it into the buffer. We are converting whatever the record that we have got. So it needs to be converted to a readable JSON format. And to convert to the readable JSON format, we are going to use this. So we are going to use this kind of line, which is constant string value buffer dot from equipment as byte to string. Now we got now we are going to pass it. So we got the value. So here is the string value that you have got. So now you are going to parse it using json.parse, and you are going to check whether the current type is manufacturer or not. So this means you are checking whether it is manufactured by the manufacturer or not, which means like first in the first stage it has to be in the manufacture state. It has to be produced by the manufacturer. If it is already available with the pharmacy, which means you are looking into wholesaling that particular equipment which is already in the state, which is already acquired by somebody else. So that is why you have to check whether the current owner is manufacturer or not. If the current owner is not manufacturer, then you cannot distribute the same equipment again to some other organization. So this will give an error. So after that, then we are going to set the current previous owner, which is manufacturer, and we are going to set it to current owner, which is the current owner that you get it from this record. Then you are going to set record.current owner type to wholesaler. Why? Because you are distributing this to wholesaler. So that is why in the current transaction, that is wholesaler distribute whatever the transaction that you have executed, the current owner is wholesaler. And then record.owner name is again the owner name that you have received as part of this as part of the parameters that you have received for this method. Then record dot last name is dt, which is the name, which is the date that you have got from the new date method. So after this, if there is any exception that happens during the creation of all this process, during the creation of this record, you will enter into this catch phase where the error is received, and it will throw an error giving the logs why this cannot be processed. If there is no error, then you will go to next section, which is await ctx dot put state, which is the same what we have done in this function, which is await ctx dot stub dot put state. The same method will be called, and you are gonna replace that particular equipment name. Replace in the sense you are just gonna um, modify that particular asset. Modify in the sense you are not gonna modify what is there in the blockchain. You are just modifying that asset. And once you propagate this transaction and all the peers agrees it, this will be stored as the next modification for the asset. So that is what that means. So once this is done, once this got executed, this particular line 96 gets executed, the asset will get stored in a new owner's name, which is the new owner that we have provided here. So this completes the second stage of the transaction. Next is pharmacy received. So this again has context parameter, equipment number, owner name. So here again you are gonna get the asset using the equipment number, and again you are gonna check whether that equipment as byte is a valid value or not. So and then you are going to convert that into usable readable JSON format, and then here you are going to parse it, and then you are going to check
Thanks for watching. Please like and share this video.
whether the current owner is wholesaler or not. Why? Because in the previous section you have mentioned the current owner is wholesale. You have mentioned the current owner as wholesaler. Before that, the current owner was manufacturer. In the next transaction, the current owner become wholesaler. In this pharma receive, you have to check whether the current owner is wholesaler or not. Once you checked whether the current owner is wholesaler or not, then you can move forward. If it is not wholesaler, then you will get an error. So once you know that it is wholesaler, then you can say record.previous type is equal to record.current owner type, which you have got it from the JSON parsed value, which you have got it from the get state method. And then you are going to say record.current owner type as pharmacy, because the current owner that the asset belongs to is pharmacy. Then record.owner type is again the parameter that you have received as part of this function. And then you are going to say record.last update, which is the same in all the three function which you got from new date. So you have created this. So if there is any error creating the statements or executing the statements within the try block, you will get an error in the catch block giving the description as well in your console. If everything goes well, then again you are going to put state. So put state is a method which you have used in all the three functions, where you are changing the values or the attributes of the asset. In this statement, you are changing the asset attributes, majorly the current owner type, and the record last updated is not majorly you are changing. So all these changes which you have done in this try block will get reflected in the blockchain. So this is all about writing the transaction methods or the smart contracts methods that are present in this pharma ledger contract. You will understand how this works when we execute it properly, when we execute it as part of a flow. So this is majorly how you actually go import all the necessary libraries and make the smart contract class, and we extend the contract, and all these methods you will describe as part of the smart contract. So this is it for this lecture. After we implemented all three equipment business function, the ledger still needs a query function to search current equipment data and query history function to get all historical records. So that is where get query by key and query history by key function comes into play. So let us look into each function to see how we get the current state of an asset or the history of an asset. In the query by key, as we already know, chain code stub is implemented by Fabric shim library, and it provides get state, which you can see here, and get history for key methods or functions. So in our case, the query function is straightforward, which we just need to call this function to get the value. So you're going to feed the key as an input value to the get state function, and you are going to get the value which you need to convert from buffer to the JSON format, and you just return the JSON that you have received from that particular method, which is get state. So this is as simple as that. Now moving on to get history by key. So as usual, you will get a key as an input, and you are going to feed that key as a key to get history for key method, and you will get the output. So get history for key returns all historical transaction, all historical transactions for that particular key across the time. So we have to iterate these we have to iterate through these records to get to get all the history of that particular asset. So we can iterate through this record and convert it into JSON format, which you can see in this line, and then we are gonna push it to a particular array so that you can display that particular array into to the user. So you are gonna define an array over here, and you are gonna define an iterator, which will gonna see whether you have the next element, you have the next element or not. If it exists, then you are going to see. If the value exists, then you are going to parse it and you are going to push it to that array. In the end, you are going to just display that particular result, which is an array which contains all the historical data of that particular asset. So this is how history function is written. So this is all for the smart contract function that we have to implement for our network. In the next section, we'll see how to compile and deploy this Fabric chain code that we have written. Thank you. See you in the next section. Before moving further, we need to install certain third-party tools for our Hyperledger Fabric network to work properly. So I have already installed these tools, and I will just tell you how to verify these tools once you install it in your operating system. It's better to use Linux, but if you are using Mac and Windows, that is fine as well. Please look into the documentation to install all this. So I am using Mac OS, so these are the couple of third-party tools that you have to install. I'll just tell one by one. Please make sure that you have installed them properly and you are also getting the same output as I am in the console. First one is the curl. So to check whether the curl is installed in your system properly or not, you have to check curl -v. This will give the curl version that you have installed. The next one is npm version. So you can see what is your npm version that you have installed. So in my case it is 6.12.0, and you have to see what is the node version that you have installed, and you have to install docker as well. So you have to see what is the docker version. You have to install docker compose. So what is the Docker Compose version that you have installed? Install Go. So Go version you can see here. Install Python. So you can see Python. And you also have to install Git for you to download the source code. So these are the major third-party tools that you have to install. So it differs from one operating system to another. The installation differs from Mac to Windows to Linux. So please go through the documentation and install all these third-party tools. Now let us get into the code. So this is the project structure that you can see for our project, which is Pharma Ledger Network. So you have these many folders. The main folders that we are focusing on is config.txt, Docker, and organization. So this has this folder structure, which you can see. So each one of them, we are going to go one by one in depth to understand what are the files and folders this folder inside consists of. That is it for this lecture. Stay tuned. Thank you. In this section, let us see what config.txt is. So config.tx.yaml file in the folder config.tx, which you can see here, it defines different organizational identities which will be used to create a consortium. The Fabric config txgen tool will generate orderer, system channel, genesis, and other related artifacts by config.tx.yaml configuration file, which is this file. Now let us see what is the content of this file. As you can see in config.tx.yaml organization section, we define orderer org, and we have other orgs, which is org1, org2, and org3 as well. Now, so inside this orderer org, you can see name of the organization, which is orderer, the ID, which is orderer MSP, and MSP dir is the file system path which contains the MSP configuration, which we have generated using Cryptogen tool. So the policies, there are two types of policies. One is signature policies and implicit metadata policy. In this network, we are using signature policies. So this defines the policies, that is, so the policies are nothing but, so when you try to, so the organization policies section, which you can see here, it defines who needs to approve the organization resource. So which you can see here in this reader section in the rule property. So you can see only orderer MSP is enough to approve the organization resource. And the orderer endpoint, the endpoint for the orderer is orderer.example.com 7050 is the port with in which the orderer is running. Coming to org1. So the org1 represents manufacturer as organization, org2 represents the distributor as organization, and org3 represents pharmacy as organization. So org1. So in case of org1, again we will give the name, we'll give the ID, we'll give the MSP directory, which the Cryptogen tool generated MSP folder, and in the policies again we are going with the signature type of policy, and here we are describing to approve the organization resource. It can be done by the admin of organization 1 or peer of organization 1 or client of organization 1, and these policies or the rules change for readers, writers, admins, and endorsement policy as well. Coming to anchor peer section. So anchor peers defines the location of the peers, which is used for cross-organization gossip communication. We have already discussed the essentialness, or we know the importance of anchor peer from the previous section. So each of the organization has an anchor peer, and it will be running at a different port for each organization, so that they are used for cross-organization gossip communication. So the configuration is same for organization 2 and organization 3 as well. In the next section, we have something called capabilities, and these capabilities are channel capabilities, orderer capabilities, and application capabilities. And these capabilities are, again, they are referenced here. So each of these capabilities, like channel capabilities, is written here, which has its own set of properties that you have to define, and it is the same for other two orderer defaults and application defaults as well. So they define application capabilities and orderer capabilities. Coming to the profile section. So the profile section defines how to generate Pharma ledger orderer genesis, including orderer configurations and organizations in the PLN consortium. So as you can see here, you have the orderer, which you have the orderer defaults you have defined before, and you have also defined channel defaults, and you have defined the orderer capabilities as well. So in the section consortium, you can see these are the three orgs which are coming together and forming the consortium. And in the section Pharma ledger channel, you can see the ledger has been created for by the communication among these three channels, which is organization 1, organization 2, organization 3, and it abides to the rule of application capabilities which we have defined in the earlier block. So this is about config tx. Now let us see what is Docker and what is the use of Docker in setting up Hyperledger Fabric network. So Docker is a set of platform as a
Thanks for watching. Feel free to add your questions as comments down below.
service products that use OS level virtualization to deliver software in packages called containers. So these containers are isolated from one another and bundle their own softwares, libraries, and configuration files. They can communicate with each other through well-defined channels. So please don't confuse these channels with the Hyperledger Fabric channels. They are different. So Docker is necessary to set up the Fabric network, and because we containerize each of the Fabric components, like we containerize peers and we containerize orderer in the network. So if you see the Docker folder which you see here, so the Docker Compose is the tool that is used for creating the containers. We are going to see how we are creating the containers. Before that, we need to configure a file, which is this YAML file, Docker Compose YAML file. This contains the configurations needed for the Fabric uh, setting up Fabric network. So now let us see what are the configuration details that we need to see in this file. So first section, you can see volumes. So volume configuration maps the directories where MSP, TLS, and other organization fabric configurations are being used in the environment configuration. And we are mentioning the network name as PLN. So these are the services that we are gonna um, um, when we execute Docker Compose. These are the containers that will come up. First one is the orderer, second one is peer 0, peer 0 of arg1, and peer 0 of arg2, and peer 0 of arg3. Now let us see the details over here. So you can see orderer.example.com, the container name is orderer.example.com. Image is the base image that we will be pulling up from the Docker hub. So when we download all the Fabric libraries, so this will be already present in your local, and this will be pulled from the local image, so which you can see here. So when we pull the image in the next section, and when we set up the libraries, you can see all the images which are already available. So if you want to override certain properties that are present in that image, you can use all the environment variables to make the necessary changes to the existing image. So working directory. So working directory attribute sets the working directory of the peer. And the command. So command is that particular command that will run when you start up the container. So these are the volume maps. Volume maps are nothing but the mapping of the volumes, where the left side is the host volume mapping, and the second one is the container volume mapping, and the same as the ports. So this is the host and the container port mapping, and the network is again what we have defined is PLN. The same configuration goes with peer 0 and peer 1 as well, keeping in mind that the MSPs of the organization and the TLS certification of the organization changes. Rest of them most of the attributes remains the same. The IP of the addresses change, and also the MSPs change, and also the ports on which the each of the services or the containers run also will vary. So this is about the configuration, Docker Compose pln.net configuration. So I'll see you in the next section. Welcome back. In this section, we are going to learn what cryptogen is. Cryptogen is basically a tool which is going to provide identities to the Fabric network entities. So for creating the network or bootstrapping the network, we need identities. So as we know, in every entity which is present in Fabric network needs an identity. So we have two options to create the identities. First one is using certification authority to create the identities, and the second one is cryptogen tool. In this project, we are going to use the second approach, which is using cryptogen tool. So there are four configurations under organization and cryptogen folder, which you can see. So each of these files, the first one corresponds to the orderer, and the three other files correspond to three other peers organization. So orderer organization. So let us look into the content of this. So orderer org defines ordering nodes and creates an organization definition. And the peer, let's go to peer. So peer org defines peer organization and managing peers and nodes. So all of these files are fed as an input to cryptogen tool, and cryptogen tool generates X509 certificates for all the organization. So if you want to see the details of the YAML files which are here. So first one is the orderer file. Here we are just gonna have the orderer, and we are just gonna mention that it is running in the local host. So when this is a special property, enable node OU. When we say enable node OU or true, which it enables identity classifications. Next, we have peer organization. So here we are representing the name of the organization and organization domain, and enable node OUs for identity classification. And here in this template, you can see count as 1, and you can see user count as 1. This creates one peer because the count is 1. And here it will create the user accounts. By default, the admin account will be created. When you say count 1, one more user account will be created in addition to the admin account, in addition to the admin users, sorry. So this is and the process continues for other two organizations as well, and it is the same for organization 3 and organization 2 as well. So we are creating one peer, and we are creating one user plus one admin in all of these organization files. So these files, when we feed into the cryptogen tool, it is going to give X509 certificates for all the organization. In the previous section, when I was talking about Docker, I mentioned about Fabric images or Fabric binaries that you have to install. So this is the step you have to follow. So here you have load fabric.sh file, which is a script file which you can see here. So this will install all the Fabric binaries to your system. So the way to install this is simply go to your terminal, and you have to change the permission for this directory, which is chmod 777 loadfabric.sh. It is necessary for Linux system, but it is good to do it. And after that, you just have to execute this particular script by doing /loadfabric.sh. So this will take couple of minutes. So that's why I have already executed this command, and the output you can see in your command, in my command line. So this is how the output looks like. And what it is doing is it is pulling all the fabric binaries from this particular URL with these versions which are mentioned here. So once everything is done, you should get the message echo, which is mentioned here, completed config setup, which you can see it over here, which is the last line for my console. So after this, to cross verify whether you have you have got all the images, you will anyway see it in the console that you have this many list of Docker images which are already downloaded as part of this process. But even if you want to check sometime later, you can just say Docker images minus a. So this will list out all the fabric binaries that you have downloaded, and all these binaries are very much necessary for fabric network to function. Okay, in this section, let us see how to generate the crypto material and how to generate the Genesis block and how to bring up the network. So first step, so before that, I have curated a couple of commands over here, which will help you to bring up the network. So I'll execute the same. So first is to feed these YAML files which are here for each organization, org1, org2, and org3, and also orderer to CryptoGen, and this will generate the certificates for us. Now let us see how it will be done. First, we are feeding this file cryptoconfig org1 to CryptoGen tool, and this should generate the certificate, and this folder has automatically come up. So as you can see, so this has inside it has 5 folders. One is CA, MSP, peer, TLS, CA, and users. So as you can see, it has its own folder structure and its own certificates associated with it. As you remember, we have mentioned we need only one peer, which is peer0.org1.example.com, and in the users you have one admin user and one extra user, which we have mentioned one in one of the configuration file. Now let us repeat the same thing for organization 2 and organization 3 as well. So we are going to feed the crypto config org2 YAML to the CryptoGen file, and we should get one more folder which has all the credentials for org2. Now let us repeat the same thing for org3 as well. As you can see, you have org3.example.com. So the folder structure remains constant across all peer organization. So now moving on, so we have to create the credentials for orderer as well. Now let us see and execute this command. So as you can see, this folder has created and it has more or less the same structure. So here you have again only one, because we have not set any other user. We have set only one, which is admin user. So this is for orderer. So we have got the certificates for both orderer and peer organization. Now the next thing is to generate the Genesis block. To do that, let's change the let's change the directory to where this file config.tx.yaml file exists, which is in this folder. Now let us go and execute this command, which should generate the Genesis block inside system Genesis block, which you can see here. So if you open Genesis block, it looks something like this because it is a certificate. So you don't have to worry about it. It is not for human readable form. Now moving on. So we have created the certificates and we have created the Genesis block. Now what we have to do is we have all the requirements required items to create the network. Now let me clear this. Now let us go and execute the network. Let us bring up the network. So now we have inside Pharma network. So we will go inside here and we have network pln.sh. So this is where this is the script which we use, and it has a command up which will, yeah, so if it is up, then
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
it is gonna bring up your network. So you can go through this shell script, which is very easy. So now let us go and execute this command, which should bring up your network. So if you have already your basic images installed, this will get automatically, I mean, this will take less time. But if you don't have the basic images installed, it will take some more time. Now let us see docker ps -a. So this will give all running containers, which you can see over here. Now let us see whether so if you get any error of any sort, then you can go to docker. You can type this command docker logs, and you can take the ID. I'm gonna see whether there is any error that has occurred during the creation of orderer container. So I'm going to take this container ID and I'm going to say docker logs. So if you see all blue items, then, and if you see all positive lines, then it means that your network is up and running. So now let me clear this. So if you can see what all the commands that are running. So first one is peer0 of arg1, peer0 of arg2, and peer0 of arg3, and orderer is also running. Now let us see how to monitor the network. So to monitor the network, so you have to download one image. So I have already downloaded the image, so that's why you can see it in logspot over here. So all you need to do is you have to go and execute the command, and if you search for this command in this netpln.sh, so you can see you're gonna so there is a function associated with it, so you can see what it will be doing and how it works and everything. So it basically takes you to this file, which is monitor.sh. Please go through this file and understand how it is doing this. It's just that it is monitoring that it is pulling a image and it is running that image. So this is the main command that you have to look out, docker run with this command. So now let us run this command. So I already have image downloaded, so that's why it is fast. Now to see whether it is working or not, let us go and access this in browser. Although it doesn't gonna give me any output, it should give me an error. So now let us go here. As you can see the errors. So this is just a demo. So if you have set up all the network identities and you want to see all the logs, this is a good place to see all your errors. So this brings up to end of this section. So let us move on, and I'll catch you in the next section. Thank you. Welcome back, everyone. This section is all about creating PLN channel. So I am going to first execute the command which creates the channel, and we will notice what are the differences that will bring into our folder structure in terms of creating new files or folders. So we will see that, and after that we'll go through a step by step understanding how and which script has created that particular file. Now, make sure before executing this command, all your Docker containers are up. Three Docker containers for organization 1, organization 2, organization 3, and one orderer container. Make sure they are up. Now I'm going to execute this command, which is the script file which is there, netpln.ssh, and the command which is inside that file is create channel. So I'm going to execute, and let's see what happens. As you can see the change here inside channel artifact, you got arg1 msp anchor.tx, arg2 msp anchor.tx, arg3, and pln channel.doc and pln channel.txt. Now let us see whether we get a success message or not. See, if you get this message, it means that your channel has been successfully joined by all the peers and also the anchor peers. Now, this completes the execution part. Now, let us understand what are the files and what are the commands that I'm executing to go through all this process to create the channel and everything. Now, let us go to this. I'm just gonna get rid of this command prompt for time being. And yeah, so in the process of creating the channel, we will use config txgen tool, CLI tool, which we have discussed before, to generate Genesis block, and then we use per channel command to join a channel with other peers. So there are several steps in creating PLN channel. So all this script logic can be found in create channel.sh, which is this one. Now let me enlarge this. So first, generating the channel configuration transaction file, which is the first command which you see, create channel transaction. So this is a critical command which is shown in this function, which is create channel transaction function, and this is a critical command which you can see here, config txgen profile, pharma ledger channel, and other parameters inside this. So what do you mean by this? This means config txgen tool reads the profile. It reads the profile pharma ledger channel section from config tx.yaml, which defines channel related configuration to generate the transaction and Genesis block. And then it creates pln channel tx file, which we have seen here, pln channel tx file, right? And the second is to create anchor peer. So we define create anchor peer transaction function here, which you can see here. So it is similar to the previous one, but we have defined different organization identity in config tx.yaml, and config txgen reads pharma ledger, which you can see in the same command. So config txgen reads pharma ledger channel organizational configurations and generates peer configuration transaction files, which you have seen in the folder structure. Then after creating anchor peer transaction after create anchor peer transaction, which is this function runs, we should see these are arg1 msp anchor.tx, arg2 msp anchor.ts, and arg3 msp anchor.tx files, which will get populated automatically. Next one is create channel using peer channel command. So before we have used config txgen, now we are going to use peer related commands, which is this function, create channel function. So create channel function uses peer channel create command to create our PLN channel. When the command is issued, it will submit the channel creation transaction to ordering service. The ordering service will check channel creation policy permissions defined in config.tx.yaml. So this line entirely indicates whatever the definition that I'm saying. So this will actually the order, and after that ordering service will check the channel creation policy permissions defined in config tx yaml file. Only admin user can create a channel. So which is what we have mentioned before, right? So using that, we also use something called set global variables, which you can see here. So we can use set global variables, which is in the script file, which I can show it. This is the script file which we are using, and this is set global variables. So set global variables in this will allow us to set peer organization as admin user, and we use org1 as admin to create our channel. So to create a channel command, the commands are okay. So we are going to see, as you can see here, for creating, we are first setting up set global variable as 1, and then we are calling po channel create command for this. So set global variables, which I've already shown in script.util.sh, has the logic. It will take certain parameters, certain import variables like core peer local msp. So it will basically have all the local variables, which are, I'll better show you. So this has all these local variables which you can see over here. So this will actually um, this function actually set other peers args as a admin user. So this is the use of setting global set global variables function. So once the channel is created, so consider that the set global variables has repeats itself, and it will create channel, and it will make the admin peers for both organization 1 and organization 2, and channel will get created. The fourth is to join uh, all the peers that are generated, all the peers that are in the that are already there to the channel. So after our PLN channel has created, we should join all these peer into channel. So this is where this function comes into picture, which is join multi-peer to channel function. So join multi-peer channel in this function will join all these peer args into our PLN channel by running channel peer channel join command. So peer channel join command, which you can see here. I'm sorry, this is for joining the multiple peers to channel, but for now we will be using join channel, which can also be used for joining multiple peers and also joining single peer. So this multiple peers channel is internally calling join peer. So join channel, sorry, join multiple peer channel is internally calling join channel. So join channel is calling the join channel has the command peer channel join, so which is responsible for joining all the peers to the channel. So when peer org joins in a channel, they need to be assigned as an admin user by calling the set global variable function, which you can see in the function, which you can see over here. And the function, and that is why it will pass this argument as a parameter. Then peer channel join command, which you can see here, will use the Genesis block to join the peer to the organization channel. I repeat, so peer channel join command will use Genesis.block to join peer args to the channel. So once the peer is joined to the channel, it can attend channel ledger block creation when creating ordering service transaction submission. So fifth is to update. So we have seen that for every organization you should have anchor peer. You should have at least one anchor peer for the communication among the organization. So for that we need this function, which is uh, update orgs on anchor peers. So at the last step in the channel creation, we need to select at least one peer as an org peer. So an anchor peer's main role is private data and service discovery. The endpoint of the anchor peers are fixed, and the other peer
Thanks for watching. Please like and share this video.
node belonging to different members can communicate with anchor peers to discover all existing peers on a channel. To update an anchor peer, we set a selected peer as an admin user and issue peer channel update command, which you can see it over here. We were giving, so this update org on anchor peers is internally calling update anchor peers, and update anchor peer is using the function calling the command peer channel update. So this is in entirety how, when you execute something called the create channel function, this is the entire process. All these functions will get executed, and the output you have seen in this section. So you can go through and you can see what on all the execution that has taken place. So you can see step by step procedure how all these process have created, and what are the outputs that it has created, and how anchor peer has joined, and these are the outputs that it has created. So if you get a successful message, it should look like this. So that is it for this section. Please go through this script file, which is create channel and util.sh, to get to know more. And please understand this, which is very important to create the channel. And creating a channel is a very important factor in Hyperledger Fabric. That's it for this lecture. See you in next one. Thank you. In this section, we'll see how we can run the smart contract. So I have already run the smart contract, which is there, this is the command that you have to use to run the smart contract. It's going to take a few minutes. So that's why I have already run and I've kept the output ready for you guys. So when you run this, so you are going to go through all these processes. If you can look into it, these are the outputs that you'll get. So we are going to look into what are all these steps in detail, but I want you guys to see the output. If you guys see, if you guys get the same output when you are executing this code, you have successfully run the smart contract. So it's going to take some time running it. It's going to take few minutes. Be patient. So if you get an end message which says it's successfully deployed on the channel, which means you have successfully deployed it and you are ready to run the smart contract. Now let me close this. So this is the main file where the deployment magic is happening. Now let us go one by one. So before going into that, now first let me explain, these are all the steps that we need to go through in order to deploy the chain code. So this was not the case before Hyperledger 2.0. Now after 2.0, all these steps are necessary to run the chain code or the smart contract. So first is packaging the chain code, second is installing the chain code, and then you will query just to make sure, and you need approval based on the endorsement policies, and you will check the commit readiness, and after that again you need approval from other organization, and again you will check for the commit readiness, and here we since we have three organization, we are going to get the approval from all the organization, and we will check for the commit readiness, and then we will commit the chain code definition, then we are going to query all committed. So these are the procedures that we have to follow, these are the steps that we need to execute. That's why there is a big log which you have seen before. So now let us get into one by one function to see what are the commands that it is executing and what is the process that it is going through. So first is we need to package a smart contract. We need to package the smart contract before we can install it to the channel. So navigate to this folder, which is manufacturer, and inside that you have something called contract folder. So inside that you have to do an npm install. So npm install will give you all the node modules that is necessary to run, and then so this npm install installs node dependencies under this node modules which I've just shown. um, Now we can start install our smart contracts by running the deploy smart contract.sh, which I have shown, and the output you have seen, the long output which you have seen. So the first step is, let me go back again, and we will start one by one looking into the function. So the first step is to package the Pharma Ledger smart contract, which is what we are doing in this particular function. So the peer lifecycle chain code package command, which you can see here, peer lifecycle chain code package command, will package a smart contract. We assign the manufacturer as the administrator. As you can see, we are assigning manufacturer as the administrator with the set global, and so as we are assigning manufacturer as the administrator user to run the package command, so that is why this set global variable 1 is there. So arg is the variable which takes the value of 1. So after this, so in the next we need to install the chain code on the on all the peers as an admin with the peer lifecycle chain code install command, which is this section. So as you can see here, this section is calling install chain code section, and inside this section we are seeing the peer lifecycle chain code install command. So so using this for loop, you're gonna iterate and you are gonna do for all the organization, which is organization 1, organization 2, and organization 3. When the chain code when the chain code package is installed, you will see the messages which you so once you execute this chain code using that deploy command which I've shown, so you can see what portion of the logs belongs to this function, this particular function, and what portion of the log belongs to this function. So you can basically segregate the portion of the logs which belongs to a particular function. So after we install the smart contract, we need to query whether so after that we need to query whether the chain code is installed or not. So we can query the package ID using peer lifecycle chain code query installed command, which you can see it here. So this is the function and this is the command that you are using. So this command completes successfully, which you have, so with which you can see the logs as well, which says installed chain code on this peer with the package ID this. So you can see that as well. So going back and forth might confuse you. So that's why I'm just showing the function execution. So after in the end, I can just relate this logs to this. So to get more deep understanding, so you have to execute on your own, and you have to segregate. You will be able to segregate the function and the logs related to that. So with the return package ID, we now have to approve the chain code definition for manufacturer using approve for my organization, which calls peer lifecycle chain code approve for my organization command, which you can see here. So you will, in this function, you are approving the chain code using this command peer lifecycle chain code approve for my organization. Now we can check whether the channel members have approved the same chain code definition using the check organization commit readiness. So you can see the commit readiness, which runs the peer lifecycle chain code commit readiness command, which you can see here. So as you can see, check or commit readiness internally is calling check or commit readiness. So which will run the command peer lifecycle chain code commit readiness, which will see whether all the members have approved the same chain code definition using this, which runs this command. So as expected, we should be seeing the output, we should be seeing the approvals for arg1. So in the output, you can see approvals as arg1 MSP, which is true, but arg2 MSP we have not approved yet. So I'll just show here so that you will get an idea, so that you know how to debug these cases. So as you can see here, this is where we are during the first iteration we are here. So for arg1 MSP it is true, and we have not got approval for from arg2 MSP and arg3 MSP. So that's why it is false. Now going back, so the endorsement policy requires at least majority of the organization that must endorse a transaction before it can commit to the chain code. So that's why we need to continue running the PO chain code life cycle chain code approve for organization command for both arg2 and arg3 as well, which is the previous command. So after that, again we need to check. So let me go here. See here, you have packaged, you have installed, you have queried. After that, you have approved for arg1 and you have checked the commit readiness, which you can see it over here in this log. And after that, again you have to do the same thing for these two as well, because according to endorsement policy, we need majority of the organization to endorse a transaction before it can commit to chain code. So that's why you have to approve it for organization 2, you have to check the commit readiness for organization 2, and you have to approve for organization 3, and you have to check the commit readiness as well. So if all the commands execute successfully, all three organization will get the approval of chain code installed, which you can see over here. So in this section, you can see what the approval status that will go on for the iteration. So in this log, you can see arg1 has approved and arg2 has approved, but arg3 is still false. In this state, you can see all organization have approved this. So this is the state where you can go. Endorsement policy has matched, so you can proceed further. Now that we know for sure that the manufacturer, wholesaler, and pharmacy have all approved pharma ledger contract chain code, we can commit the chain code, commit the definition. So we have required majority organization, which is 3 out of 3, to commit the chain code definition to the channel. Any of the three organization can commit the chain code to the channel using peer lifecycle chain code commit. So let me just go to this. So here, any of the peers can use this command peer lifecycle chain code commit in order to commit the in order to commit the definition using this command. So after this, so we will use this command, which is query command, to check whether to check this chain code commit status. So we use this peer lifecycle chain code query committed command to see the to check the chain code commit status. So these are all the functions that you need to go through. And to summarize, so there are different stages where your chain code has to go through before it commits to the blockchain. So first it has to be packaged, and then you have to install the chain code, and then you have to query the chain code. And you, according to endorsement policies, if your endorsement policy says that majority of the organization have to approve, then you have to take the approval from all the organization. That is what we are doing in approve for my org, which is passing one, which is manufacturer. Approve for my organization two, which is um, distributor. And approve for my organization 3, which is pharmacy. So this is what we are doing. And then we will see the commit readiness. So once the commit readiness has achieved, we will get true for true from all the organization. So at this point of time, endorsement policy matches, and then we can go, and any of the peers, either peer 1, peer 2, or peer 3, either manufacturer or distributor
Thanks for watching. Feel free to add your questions as comments down below.
or pharmacy can go ahead and commit the chain code definition. After that, you can query all the query the chain code. So this is what the logs as well, so which you have seen before. This is quite a long list of logs. So you can just execute this command, and you can relate this. You can just go to one function and try to see the log, what are the logs related to that particular function. In that way, you will have a better understanding of this life cycle of the smart contract. That is it for this lecture. Thank you for watching. Welcome back, everyone. In the previous section, we have seen how to deploy the smart contract. In this section, we are going to see how we are going to test those smart contracts. Let me close this. So we have written couple of smart contracts, and we have deployed the smart contract based on the use case that we are going through. So I have curated the commands that you have to execute in order to test the smart contract. So as part of the first flow, so we have to add an equipment to the through the smart contract. We have to add an equipment to the blockchain. So this is the command that you will be executing for adding an equipment to the blockchain. As you can see, the output that you got here is invocation successful, or invoke transaction successful with this channel ID. And you can also see chain code invoke success and result as 200 response. This means if you get a 200 status response, this means you have successfully saved an asset to blockchain. Now let us go through this, and let us see what are the parameters that it is taking. As we have already seen in the smart contract, if you go to the wholesaler, if you go to make equipment, so as you can see, it takes 4 parameter. First one, manufacturer, equipment name, and owner name. So let me copy this and paste it below. So as you can see here, the parameters are: manufacturer is by the name Global Equipment Corporation, and equipment number is 2000.001, and equipment name is E360 ventilator, and owner name is Global Equipment Corporation. So now this equipment by the identification number 2000.00001 is there in the blockchain. Now, just to verify, let us invoke this query command to see the result of this invocation. So we are trying to get the asset value which we have just created, which is the equipment. As you can see the result over here, let me increase the size of this. So as you can see the result, this gives the key 2000-001 and the equipment details, which is exactly what we have given in this command, which you can see here. So this proves that your adding your equipment to the blockchain is successful, and you can also query the asset. Now let us move on to the next flow. Next flow is, and it has to be passed, the equipment has to be passed to the wholesaler. Now before executing, let us go to the smart contract and take the parameters that we are trying. So this is the function we are trying to execute here, which is wholesale distribute, and we are going to map those parameters here. Here, as you can see, equipment number is 2000.001 and owner name is Global Wholesaler Corporation. Now let us execute this command. As you can see, again you got chain code invoke successful with 200 message. Now just to again verify, you can invoke this command as well. Now you can see the difference between this and the previous one. So now let me just go here and paste, and let me go to the previous. Okay, we have cleared the previous console, but that's fine. So what I'm trying to explain is, as part of the execution, chain code execution, now the owner name is not the manufacturer. Now the owner name is Global Wholesaler, which is what we have mentioned here in our smart contract. So this is correct. Now let's move on to the next phase. So the next phase is passing on to a pharmacy. So this is the command that we will execute. Now let us clear this, otherwise it will be confusing. So I have cleared the output from the previous command. Now this is the command that we will be executing as part of the next phase. As you can see here, you again got a chain code 200 response, and let us again invoke a query to see the status of that particular asset. Now let me copy this output and verify with the previous output to see the difference. Let me close this. As you can see here, the manufacturer attribute stays the same, equipment name stays the same, but if you can see owner name, now the owner name is changed to Pharmacy Corp, and you can see previous owner type is also changed, which is wholesaler, and current owner type is pharmacy now. Previously it was wholesaler. So these are the changes that you can expect during the flow. Now let us clear this console. Now there is one more command that we have to execute to see the history of that asset. Now let us invoke this. Before invoking this command, let us see what is the smart contract or the chain code we have written for this. So this is the method that we will be invoking as part of running this command. As you can see, we are passing only the key as a parameter, and this function get history for key will get all the details, all the historical details. Let us see what will be the output of this command. As you can see, this is the output of that command, which is an array. Now let me take this and paste it here. As you can see, first it was with manufacturer, and sorry, let me go from left to right to see the details. So first it was with manufacturer, and then as we move ahead, so this record shows it is with manufacturer. Now, okay, where is the next one? Okay, from here it says that the owner is wholesaler after the owner has changed to pharmacy. As you can see, this output, so there are three events that this asset has gone through. So first one is the owner is Equipment Corporation, Global Equipment Corporation, and after that the owner has changed to Global Wholesaler Corporation. Now the current owner is Pharmacy Corp. So this tells the history of the asset or the transaction that the asset has gone through. So this completes invocation and testing of the smart contract that we have written in this Pharma Ledger contract.js. Thank you for watching. I'll see you in the next section. In the previous section, we have deployed the smart contract, and we have also seen how those smart contracts can be invoked using command line. In this section, we are going to develop an application with Hyperledger Fabric through SDK. Now let us look into the network section. This is how the network looks like when we try to have a common connection profile which we have generated before for organization 1, organization 2, and organization 3. I'm gonna again show you how we can create this common connection profile in the practical section, which is in a couple of minutes. So we will use these connection files to connect to our PLN network for each peer organization. Now let us see. If you consider this as web or the browser with which we are using, we are trying to get in touch with the blockchain. So for that, we need a wallet to identify a client or an application, which is we are gonna create a client Bob, and then Bob will gonna interact with the blockchain by connecting to a peer using a gateway. So we are going to see all this, how the coding is done in few minutes. Let us just focus on this diagram and understand how the application is connecting to the blockchain in its entirety. As we have seen, through web browser with the use of wallet to identify a client Bob, he is going to connect to a gateway which in turn connects to the peer in the blockchain. And it is the same for the other users in the network as well. If we consider Bob as a manufacturer and Alice as the wholesaler, and we are going to consider Eve as the pharmacy person. Now we have created all these three clients, and we have created wallet identification for all these three clients. So using those wallet identification, each of these user connects to the peer in the network, and that connection, using that connection, you can invoke the transaction just like we have done using the command line interface, which we have seen in the previous section. Now, this is how the application will interact with the blockchain network. Now let us understand how this is achieved, and let us see how this application looks like when we build this application and try to connect to the blockchain network, which we have already built, and we already have the smart contracts or the chain code deployed on it. Let us go to the VS Code. As you can see, inside organization section, which is this, inside organization section, you have three major folders. One is manufacturer. I'm going to close all this. So one is manufacturer, pharmacy, and wholesaler. Inside both of this, you have one special folder, which is application. So application is where the application code resides. So let us go to PLN client here, and there is one more important file, which is app.js. Now let us understand, if you understand one file, it's the replication of the same for other two users as well. For example, other two users meaning the
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
pharmaceutical guy and also the wholesaler guy. Now let us understand this. So this is the main file where you are going to import all the details. So we are using Express framework to build the front end application. So we are using Express to build this application of ours, which is going to interact to our blockchain network. The main thing that you have to take account here is we have this fabric network with which is used to import the wallets which we are going to generate. So this is the code where we are taking the wallet information from our local system, and we use that wallet information in order to talk to the endpoints that we have created. So these are the endpoints. As you can see, you have add user endpoint, we have make equipment endpoint, you have query history by key endpoint, and you also have query by key endpoint. Let me explain these. And okay, so add user. As you can see here, when the request comes to this, when the request hits this endpoint, it is going to take the username and it is going to do a check on the username. Then it will add that username to the wallet. So when you do this, a user identity will get created in your user structure. We will see the change of structure in few seconds. It's the same with the make equipment as well. So you will get the requested parameters from the UI, and we will get all those details using these instructions which you can see here. And all those parameters we need to pass as a parameter to the transaction that we are supposed to invoke on the blockchain. As you can see, all these parameters we need to pass to make the equipment. So we are going to pass this equipment to this make equipment function. If you get the result, that means if you get 200 result, that means it is successfully stored on the blockchain. Now get query by key. In this, you will be needing the username, and here after that you are going to pass a key. So with that key, which is nothing but the manufactured equipment ID, with that key, you are going to invoke the history of that key. After that, you can also get the information of that particular equipment using this query by key endpoint as well. And for all of this, the different functions get executed. So this is how it looks like, and it is the same for wholesale and also pharmacy as well. Coming to one more important file, which is this file. So here in this JS file, you have to mention a unique URL base where your application expose itself. So these are basics jQuery functions. If you are familiar with JavaScript and jQuery, this should be pretty easy to understand. So I'll just explain one. So as you can see here, when the user clicks on add user button, the URL will get selected and it is gonna hit this endpoint add user over here, and it is gonna pick up the value that the user is giving as the username. Then we are gonna make an AJAX call. AJAX call is nothing but you are gonna hit a particular backend endpoint, in our case endpoint which is add user, and we are gonna hit that endpoint with the parameters to get the response back. And it is the same for other buttons as well. So this is the main functionality that you have to keep in mind, and it is a repetitive process. If you understand how to do it for one one of the folder, for example, if you learn how to do it for manufacturer, it's the same for pharmacy and wholesaler as well, keeping in mind that you have to change the base URL. That is all you need to keep in mind. Now let's get into the practical stuff and see how this works. Now let me close this. So as I told before, this is the command that you need to run to generate the generate this file, which I'm going to show it here, which is this connection profile file, right? Connection.org1.json, connection.org2.json, and connection.org3.json. So this is the command that you should execute. Since I've already executed, I already have that in place in my ecosystem VS Code. Now let me enlarge this and make sure your Docker containers are up and running, and you have created the channel and you have deployed the smart contracts and everything. Now let me go to organization, manufacturer, application. Now we will execute this. Now as you can see, our first application, that is manufacturer application, is available at this URL. Now let me close all this and open only manufacturer. Now as you can notice, you have public service and views, and you also have node modules because you have to install npm install inside this. Since I've already installed that, I have node modules. If you don't have this node modules, please go ahead and execute npm install inside this application folder. Now let us go to the browser and hit on this URL. As you can see, you will get this UI. Now let us add Bob. Sorry. Let me add Bob. So if you get this message, Bob was successfully added to wallet and it is ready to interact with the Fabric network. Okay, well and good. Now if you go to your VS Code and look at the structure, as you can see, there is one more folder which got automatically created, which is the identity folder. Inside this you have a wallet folder which has identity for Bob, which we have just created. Now in the console you can see the output as well. Now let us go and make equipment. So I am giving values as this. You can give anything you want. So let me submit this transaction. This transaction will store this particular equipment in the blockchain. As you can see, successfully record manufacture equipment in the blockchain. This means this asset is stored in the blockchain. Now let me query this asset in the blockchain. As you can see, the query result, Now the current owner type is manufacturer and the previous owner type is also manufacturer. Now let me see the query history. So the query history makes sense at the end of the life cycle, but at this point of time, the history of this asset is only one record. Now let us go and open up one more terminal and let us do the same thing for wholesaler, because that is the next logical step or logical explanation in our life cycle of uh, this manufacturing life cycle. Now let me go to Pharma ledger and organization, and let me go to the wholesaler and application. Now let me execute node app.js. So as you have seen, it is running on localhost 300001, sorry, 0001. Now let me call this user as what was the previous one we have called. So for the manufacturer we have added as Bob, and for this we are going to add as Alice. As you can see, Alice was successfully added. Now if you see the wholesaler, the identity has been added, which is Alice. Now let's go and invoke the transaction for distribute, wholesale distribute. Now let me submit this and wait for the transaction to finish. As you can see, the blockchain has successfully captured this record. Now let me query this here. As you can see, previous owner is manufacturer, but the current owner is wholesaler. Now, if you go for history of this record, you must find two records over here, which is the same thing. But is it available only in this node? No, it's available in this node as well. As you can see, I'm querying the same history for that equipment in manufacturer as well. You can see the same two records. Now to complete this life cycle, let me go and execute the same instruction for pharmacy as well. Organization, pharmacy, application, node app.js. Okay, this is running in 3002, localhost 3002. As you can see, this is pharmacy. I'm gonna call this person Eve. Sorry, Eve. As you can see, Eve was successfully added, and if you go to your VS Code, you must see a Eve identity added. After that, you're gonna go and go for pharmacy received. This completes the transaction from wholesaler to pharmacy. Now let us just query for the key. Now as you can see, the previous owner is wholesaler and the current owner is pharmacy. And let me query the history. You should see 3 records here. As you can see, this is 3 records, and it is the same with other peers as well, because it has come to a consensus and it has updated its ledger data. So this is how we are going to build the distributed application and see how it works. So it's very simple. If you learn for one, and you should be good to go for others as well. So this is a very simple example of how you can modify your wallets, and you also can modify and play around with your front end as well. That is it for this lecture. Please do practice this. This is a very interesting section, which is very useful for you to pictorially or visually present how blockchain works. So if you have any doubts, please feel free to reach out to us. Thank you for watching.